Every time we launch a satellite or send a rocket into space, we leave behind bits and pieces that float around, posing a danger to other spacecraft. These fragments can collide with operational satellites, causing damage and creating even more debris. This buildup of space junk isn't just an inconvenience, it's a threat to our ability to explore and use space in the future. If we don't address it, it could make space travel more dangerous and even limit our access to vital services like communication and weather forecasting. So, let's take a closer look at this issue. What exactly is space pollution? How does it happen? And what can we do about it? Join us as we explore the facts behind this pressing question. Are we polluting space? Let us begin with understanding. Since the dawn of the space age in the 1950s, humans have been launching rockets and satellites into orbit around Earth. But as we've ventured further into space, we've also left behind a growing amount of debris, creating what scientists call space junk. So, what exactly is space junk? It's any man-made object left floating in space, from defunct satellites to discarded rocket stages. Even tiny flecks of paint can become space junk if they're shed from a spacecraft. Imagine thousands of dead satellites, along with countless bits of debris, orbiting our planet. This clutter poses a significant risk, especially as we continue to launch more rockets and satellites into space. Each launch adds to the congestion, increasing the likelihood of collisions. Currently, there are about 2,000 active satellites orbiting Earth, but that's just part of the picture. There are also over 3,000 dead satellites and an estimated 34,000 larger pieces of space junk, each at least 10 centimeters in size. And that's not all. There are millions of smaller pieces too small to track, but still capable of causing serious damage if they collide with something else in orbit. To put it simply, space junk is becoming a crowded and hazardous environment. As we continue to explore and rely on space for communication, navigation, and scientific research, it's essential to address the growing issue of space pollution before it threatens our access to the cosmos. Space debris has been accumulating in Earth's orbit since the historic launch of the first artificial satellite, Sputnik 1, in October 1957. However, even before this milestone, human activities might have contributed to space debris, as evidenced by events such as the Pascal B test in August 1957. Furthermore, natural ejecta from Earth itself has found its way into orbit, adding to the debris. Following the launch of Sputnik, the North American Aerospace Defense Command, NORAD, took the initiative to compile a comprehensive database known as the Space Object Catalog. This database cataloged all known rocket launches and objects reaching orbit, including satellites and components of launch vehicles. NASA later published modified versions of this database, facilitating the tracking and monitoring of space objects. NORAD trackers, responsible for maintaining the database, were aware of various objects in orbit, many of which resulted from in-orbit explosions. Some of these explosions were deliberate, occurring during anti-satellite weapon testing in the 1960s, while others were accidental, caused by rocket stages rupturing their tanks. Over time, more detailed databases and tracking systems, including Gabbard diagrams, were developed to better model orbital dynamics. Despite efforts to track and monitor space debris, clearing it remains a challenge. While gravitational and atmospheric effects do contribute to debris removal, technological solutions have been proposed but not widely implemented. Scholars have identified systemic factors, political, legal, economic, and cultural, as significant barriers to effective debris cleanup. Currently, there is little commercial incentive to reduce space debris, as the costs are spread among all users of the space environment. In response to the growing concern over space debris, NASA established the Orbital Debris Program in 1979 to research mitigation measures for space debris in Earth's orbit. However, addressing the issue requires not only technological innovation, but also changes in policy and incentives to encourage proactive debris management. All space junk originates from human activities, primarily through the launching of objects from Earth into orbit. These objects remain in orbit until they eventually re-enter Earth's atmosphere. Objects in lower orbits, typically within a few hundred kilometers above the Earth's surface, have shorter lifespans and tend to re-enter the atmosphere relatively quickly, usually within a few years. Upon re-entry, most of these objects burn up in the atmosphere and do not pose a risk of reaching the ground. However, debris or satellites left at higher altitudes, such as those in the geostationary orbits around 36,000 kilometers above the Earth, can remain in orbit for much longer periods, sometimes hundreds or even thousands of years. Space junk can also result from collisions between objects or from anti-satellite tests conducted in orbit. When two satellites collide, they can fragment into thousands of smaller pieces, generating a significant amount of new debris. While such collisions are rare, several countries, including the USA, China, and India, have conducted tests involving the destruction of their own satellites using missiles. These tests create thousands of additional pieces of hazardous debris, further contributing to the growing problem of space junk. During the 1980s, efforts to curb the growth of space debris were initiated by NASA and other U.S. organizations. One such attempt involved a trial solution implemented by McDonnell Douglas in 1981 for the Delta launch vehicle. This solution required the booster to move away from its payload after launch and vent any remaining propellant in its tanks. By doing so, it eliminated a source of pressure buildup in the tanks that had previously led to explosions and the creation of additional debris. However, adoption of such measures was slow in other countries, and with numerous launches by the Soviet Union, the problem of space debris continued to escalate through the decade. A 2006 NASA model projected that if no new launches occurred, the population of space debris would remain relatively stable until around 2055, after which it would increase on its own. Richard Crowther of Britain's Defense Evaluation and Research Agency suggested in 2002 that this cascade effect could begin as early as 2015. Additionally, the National Academy of Sciences warned that 2 bands of low Earth orbit space were already past critical density, posing significant risks to spacecraft operating in those regions. In 2009, researchers at the University of Southampton predicted that the threat from space debris would increase substantially in the coming decades. By that time, more than 13,000 close calls with space debris were being tracked weekly. A 2011 report by the U.S. National Research Council emphasized the critical level of space debris in orbit, warning that the existing amount could lead to continual collisions and the creation of even more debris, heightening the risk of spacecraft failures. The report called for international regulations to limit debris and research into disposal methods to address this pressing issue. The Kessler Syndrome, proposed by NASA scientist Donald Kessler in 1978, is a concept that warns of a potential catastrophic chain reaction in the Earth's orbit caused by an excessive amount of space junk. According to Kessler, if the density of space debris reaches a critical point, collisions between objects could lead to the creation of even more debris, eventually rendering Earth's orbit unusable. While this scenario may seem extreme, some experts fear that a variant of the Kessler syndrome could become a reality if steps are not taken to mitigate the growing problem of space junk. This idea gained widespread attention following its portrayal in the movie Gravity. Looking ahead, space junk could indeed become a significant issue. Several companies, including SpaceX and Amazon, are planning to launch vast constellations of satellites to provide global internet coverage. If successful, these mega constellations could add tens of thousands of satellites to Earth's orbit, increasing the risk of collisions and the need for frequent collision avoidance maneuvers. In September 2019, the European Space Agency performed its first satellite maneuver to avoid colliding with one of these mega constellations, highlighting the growing concern over space debris. To address this challenge, it's crucial to ensure that satellites are removed from orbit in a timely manner once they are no longer operational. By taking proactive measures to manage space debris, we can help sustainably utilize Earth's orbit for vital activities such as Earth observation, communication, and scientific research, ensuring that future generations can continue to benefit from the opportunities it offers.